Thank you for viewing this recorded Reliable Automatic Sprinkler Company webinar. Should you have any questions regarding this presentation, please feel free to contact Reliable Technical Services at 800-557-2726 or email us at techserve@reliablesprinkler.com. For upcoming webcasts and an archive of past webcasts, please visit reliablesprinkler.com/webcasts. Once again, thank you and enjoy the presentation.
Okay, well, thank you. And thank you to those who are joining us here on the Fire Protection Series presented by Reliable. Today, we're going to discuss the latest updates to FM Global Datasheet 8-9. The latest interim revision to Datasheet 8-9 was published in July of 2021. And then we're also going to talk about how some of those changes in 8-9 compare with the latest requirements in the now 2022 edition of NFPA 13 that's available. Joining us today is Wes Baker with FM Global. Wes, thank you very much for joining us. Could you start off by telling us about your role at FM?
Steve, thank you very much. So I must admit, I have like the best job on the whole planet. So here's what I do. Let's look back at a test that we did back in 1972 involving something simple like hanging garments, 7 foot high under a 9 foot high ceiling. Now, back in those days, we didn't have the ESFRs we have today. What we had, though, was standard response K5.6. And what we've done with this is we've installed it under a horizontal barrier and provided a 0.26 density. So here's what I get to do. I get to light things like this and see whether or not they work or not. So as we watch this video, you can see sometimes we have good days, sometimes we don't, but we learn from it and we get a chance to then take that information and document it in our data sheets and provide it to our clients for best protection when it comes to their property and time element business interruption protection. So here was one that kind of got away from us. So I always tell people I've got the best job on the planet. I get to run tests like this, but I also have to document the results. And that's part of writing data sheets that you see from FM Global. And here's the ones I'm generally responsible for. We'll start with 2.0. That's our guidelines for how to install sprinklers in a facility. And then 3.0 looks at how to calculate those sprinklers from a hydraulic standpoint. And then I've got some storage data sheets that I'm responsible for. You just saw the one on hanging garments, but I also have 8-9, which is class 1 through 4 in plastic commodities, 8-24, which is idle pallets. And then 833 and 834 look back at those same class 1 through 4 in plastic commodities, but just in a different storage arrangement. And the nice thing is every once in a while, I get to go out and do public speaking on these data sheets. In addition to writing data sheets, I also do internal training at FM Global. And so I teach any new hire going through FM how to apply the guidelines you see in 2.0. How do you apply the guidelines in 3.0 for sprinkler hydraulics? And of course, my favorite data sheet 8-9. But I also get to do stuff outside of FM Global too, and that's working on NFPA 13 for both the installation and discharge committees. And sometimes I do take time off and love to play golf, but sometimes even when I do that, my job follows me wherever I go. So that's basically what I do in a nutshell.
Thank you, Wes. And are there any specific FM Global data sheets commonly used for storage that you wanted to highlight beyond what you had a second ago?
Yeah, actually, when you look at storage, when it comes to the data sheets we have, well, I'll go back to the list that I've got. And what I'll do is I'll list the top 5 data sheets that are used for storage that are downloaded by our clients or contractors out there. And one of the top ones that's always downloaded is our installation guidelines in 2.0. It's one thing to go into a data sheet and get the design, but we want to make sure that the sprinklers are being properly installed. Another one that's very commonly used is 8-9, which is any type of storage arrangement, either solid pile, palletized, shelf, or bin box storage, and as well as racks for class 1 through 4 in plastic commodities. Idle pallets, everybody wants to know how to protect them because you always find those in warehouses. And one of the data sheets that's really become very used a lot in a lot of warehousing is our automatic storage and retrieval systems. Lots of warehouses going to that type of storage array. And so we updated that data sheet back in 2017, and it's been one of the top downloaded data sheets ever since. Of the top 5, I'd like to claim I have all top 5, but no, there is one more data sheet out there that people do download quite a bit, and that's our guidelines in 729 for storage of ignitable liquids, and that's handled by John LeBlanc. Now, one thing I do want to let everybody know when it comes to our FM Global data sheets, they can get them free online at www.fmglobal.com. So if you go to that website, it kind of looks like this. And what you would do is look for the Research and Resources tab. You click on that. That'll bring you to the data sheet section. And all you have to do is click on the subscribe button, and away you go. You can get all of our data sheets for free.
Okay, and today we're going to focus on some changes to Datasheet 8-9, but before we get into that, can you tell us about the process for revising FM Global data sheets? How do those changes come about?
Oh, sure. In fact, the process for doing this over the years has changed a little bit. We're kind of, I almost want to say, we're kind of like NFPA 13 now. It all starts with feedback. So just like the NFPA 13 process where you have public inputs, we get data sheet feedback, and anyone can provide feedback on data sheets that you look at. If you don't happen to know my number or my email, we have a generic email system that you can send feedback to, which is datasheetsfeedback@fmglobal.com. And what we do is when we collect that feedback, we put it into spreadsheets. So we collect, what section is affected, who submitted it, what's the suggestion, what's my thoughts on it. But it's not just me. So what I have going for me is what we call a data sheet support team. And what that includes is various members from all around the FM Global company, such as myself, like the subject matter expert. But we also have chief engineers throughout our world operations, and usually we have to have at least one from the US and one from somewhere outside the US that sit on that. We also have field engineers that sit on it, so we get both US and non-US input. Account engineering takes care of that. Research is part of that program. Our friends from FM approvals are part of that, our training section, and of course, underwriting wants to sit on and find out what we're doing and make sure that they'll know how to properly underwrite things and what impact that might have to underwriting for clients. And just like NFPA 13, we have various drafts that we go through. We have a first draft, and then based on feedback from there, we create a second draft. Then our final draft is what goes off to our senior management for review. Now, unlike NFPA, though, we have a chance to get our data sheets out on a relatively quick basis. So 4 times a year, but every 3 months, a data sheet has a chance to be released so that you can get the latest, greatest recommendations we have in our data sheets.
Yeah, I think we've noticed that's the updates, especially at 8-9, have become more frequent in the last few years. And so that's real nice with things changing in the industry, new storage arrangements. It's good to see the latest guidance coming out quickly with that. So speaking of updates to guidance, how does a user of one of the data sheets identify the most significant revisions?
Well, yeah, that's I know that's always been something that in the past people have always asked. You make a change, how can I tell what you've done? Well, we've created a means that any user can then sort of get an idea of where these changes take place. And so when you look in our data sheets, there is a section that we've created, 1.1, right, almost kind of at the very beginning of the data sheet. And what that section does, it gives you a listing of the significant change. Now, it doesn't give you every single change that takes place within data sheet, but at least the ones that we feel are significant. But if you want to read into it more, then what you can do is just go read through the entire data sheet and find anything in red is something that's been changed. So that gives you an idea as you read through it If you're familiar with the previous guidance that has been in it, it also gives you an idea of what is new compared to the last time we updated it.
Okay, well, and let's dive into those changes, the recent changes in the July 2021 revision to datasheet 8-9. And one of the first changes occurs in section 2.2.3, where the title of that section has been changed from flue spaces to storage arrangements.
Mm-hmm.
So maybe seems innocuous enough at the beginning, but why was that change made? And aside from the title itself, how are the new requirements applied?
Yeah, great question. Because one of the things that section 2-2-3 used to be, as you mentioned, just it was about flue spaces. And so a lot of times people would go in there and they would try and find out what's required for flue spaces. And that section kind of focused in on the flue spaces for rack storage where you had ceiling only protection. Then there was a section on what if I had ceiling and in-rack sprinklers, what were the flue spaces required? And lastly, the last section there was our solid pile palletized shelf and bin box storage. But what we found was that really what we were driving at is to trying to find flue spaces that ended up being an acceptable storage arrangement. So what really it was a change to try and drive people to kind of really look at what makes up an acceptable storage arrangement. And so our first section basically took the previous guidelines, moved them up to the beginning for solid pile palletized shelf and bin box storage. There really wasn't any major changes to that. But what came into play now was looking at the fixed in place rack storage arrangements. So those are kind of, I'm highlighting here in terms of single row, double row, and multiple row racks. There's always been questions about, how do we set these up so that they're open frame? So one of the things we did is really went in there and tried to demonstrate what that was. And I've learned over time that whatever I have in terms of my head that I try to put on a piece of paper and write it properly, it's not always clear to everybody else. So one of the things that we did this time around is we added figures to try and demonstrate what the text was trying to tell them. So for example, here's a example of a double row rack where you have no misaligned flue spaces and you've got transverse flue spaces roughly every 4.5 feet apart. So if that's the case, then you can have a transverse flue space that's as small as 3 inches net wide, or 75 millimeters. And then we give you an elevation view that shows exactly what is happening as well when you look at it from a plan view situation. Now, fortunately, we made a little editorial mistake, and when you see a minimum net 6 inch, that's really supposed to be a minimum net 3 inch. So we're fixing that, and as I mentioned, you can get those data sheets out pretty quickly. We're going to have that revision out for January of 2022. So here's a case where we're trying to demonstrate using figures in addition to the text what constitutes adequate flue spaces in your rack storage arrangements that will lead you to be able to qualify that rack, whether it's single row, double row, or multiple row rack, as a open frame racking system for protection purposes.
And, related to storage arrangements, one of the key changes, one of the big things to watch out for in the 2022 edition of NFPA 13, which was recently published, is a significant change that limits the overall depth of multiple row racks where the individual pallet loads are not surrounded by 6-inch flue spaces. And so that's something that as someone might be going through the latest requirements in 8-9, where it has some additional guidance, additional figures on storage arrangements. And if you're working in jurisdiction where you're also using the latest edition of NFPA 13, you might see you should watch out for changes to multiple rack allowances in 13 also. Anything to add to that, Wes?
Oh, certainly. I mean, this is going to be big. When you look at multiple row racks and what is going to be in NFPA 13, which I believe is coming out this month if it hasn't already, is a huge change when it comes to the definition of an open racking for multiple row racks. So let me start with 8-9. So when you look in 8-9 in section 223 for storage arrangements, you basically have two options available to you to qualify the multiple row rack as being an open frame. And option one looks at situations where you are, in essence, as Steve, as you said, providing a 6-inch not only transverse flue space, but longitudinal flue space as well around every pallet load. So if I were to kind of look at that from a plan view, you can see that I've got it's almost looks like a double row rack. It's just I've got more storage that makes it deeper than a double row rack. And back in the day, you know, when I started with FM, that's kind of what we saw. We used to see two double row racks placed back to back, and you would have, you know, what could have been 6-inch flue spaces around every pallet load. Well, that's certainly changed nowadays. So what we're looking at now is cases where we have pushback type racking, which is starting to make up just about all the multiple row racks we see out there in warehousing. Now, option two becomes what happens if I eliminate the longitudinal flue space between my pallet loads? Well, you can do that. You still have to maintain those 6-inch wide transverse flue spaces, but now your rack depth can only go back as far as 20 feet, and I need to separate the front and the back of the rack with an 8-foot wide aisle. So when you look in 8-9, this is kind of what you see. You'll see a figure that represents the maximum 5-foot wide loads with minimum 6-inch net transverse flue spaces, at maximum 20-foot depth on the rack, and separated by minimum 8-foot wide aisles. Not something that's probably going to be very palatable to a lot of warehousing when you see that. But when you look at NFPA 13, it's basically the exact same guidelines. The only thing that's changed is that their aisle width separating the 20-foot deep wide multiple racks, they use a minimum 3.5-foot wide aisle to define where that rack ends in terms of its depth. So what I'm getting is a lot of questions. Why the change? You know, what we used to have in NFPA 13 was an unlimited depth. So there was no 20-foot maximum allowable on this. You could go as deep as you wanted. Well, what happened during this last cycle, a public input came in to look at that further and see if we really needed to provide a maximum depth or limit the depth of our multiple racks. So we decided to go back and look at what testing had been done on multiple row racks with ceiling only protection. And we went back all the way back to March 7th of 1971, because that's the only one we have available that gives us any data. And so what happened, this was done as part of the Rack Storage Fire Protection Committee, where the testing was done at FM Global, but it was done on behalf of NFPA and to create data points for 231 in NFPA. Now, what was tested was class 2 commodity up to a height of 20 feet, as you see in this picture here, under a ceiling height of 30 feet. That was typically what a lot of the testing was back in the late 60s, early 70s for the Rack Storage Fire Protection Committee. Now, in this case, we had a 6-inch wide transverse flue space every 5 feet. There was no longitudinal flue spaces provided. The depth of the rack was 16 feet. And so when you look at the class 2 commodity, it was basically a 48-inch by 48-inch cube that was about an inch of cardboard surrounding a metal container. And so it kind of simulated what your commodity might be back in the days if you bought a dishwasher or a refrigerator at a store. Here's how it was stored in the warehouse. And what separated those racks back then was 10-foot aisles, because that's what the forklift drivers needed to maintain enough space for material handling purposes. Now, what we put up at ceiling level for the protection back then, you have to remember, all we had was K5-6 sprinklers. So they used a K5-6 sprinkler that was upright. It was standard coverage and it was standard response. The temperature rating was 286 nominal and installed on 10 by 10 spacing. Now the density they used was a little higher than normal. Most of the testing back then was conducted with a 0.3 density. In this case, they ran it with a 0.45. And what happened during that test, we got fire control. 12 sprinklers operated and control the fire. So in that case, the committee decided, you know what? We ran a test. It looks like the results we get with multiple row racks are very similar to what we get for double row racks, which is great because that way all you have to do is test is double row racks, and we can apply the results for our double row rack test to both single row, double row, and multiple row racks. And that way we can cut down on the number of tests we have to run for multiple row racks, and they're less costly that way. Problem is that they never did a test that matched exactly what was tested with a multiple row rack with double row racks. So there really wasn't anything of a comparison to say, okay, how would a double row rack react compared to what happened for multiple row racks? So it left us with this one and only test. So when we look at these multiple row racks, it brings up some concerns, because when you look at our double row rack tests, we can see that we have 6-inch flue spaces for transverse every 5 feet. In addition to that, we do have a 6-inch wide longitudinal flue space. So when I look at the amount of shielding I might have during a fire, it's basically one pallet load, which tends to be about 20 square feet in size. So if I have a fire that originates somewhere in the middle of that rack, now excuse my crude illustration here, I'm going to look at a very low area of shielding that takes place as that fire makes its way up to the ceiling. Now, when I look at a multiple row rack, though, things are a little bit different. So if I don't have any longitudinal flue spaces, that's going to allow for propagation of the flame spread underneath those pallet loads. And so it's going to go from anywhere that's taking place within the rack, and it's going to spread to wherever I can vent it vertically. And that would be at one end of the multiple row rack and the other end of it. So I end up with a much larger shielded area. And as a result, datasheet 8-9 and NFPA 13 now limit these multiple rack conditions to what was tested until we can do more testing in the future to find out how do we protect these. Because right now, if you have a multiple row rack that's deeper than 20 feet, now it defaults to racks that's with solid shelving. Even though they don't have it, you'd have to protect it as that's what's there. And when you look at the size of the shelf area, it's more than 64 square feet, which is going to default to in-racks installed at every tier level. So I don't think anybody really wants to do that unless they absolutely have to. So the hope is, hopefully within the next 3 years or so, we can come up with some new testing and find out where we fall off the cliff so that we'll know what level of protection to provide, both for new locations as well as existing installations.
So another hazard that's becoming more common that we hear about a lot now is open top containers. And we get a lot of questions into Reliable Technical Services about how do we protect open top containers in storage. I see that section 2.2.4 was modified in datasheet 8-9 on how to either eliminate or protect the hazard of open top containers within storage racks. Can you talk about what 8-9 recommends for open top combustible containers?
Sure, it's not much. So when we look at open top containers, combustible containers particularly, there's basically 2 types we're coming across. When you look at the types of containers you would find that 8-9 applies to. Now, in this case on the left, we have containers that are about 2.5 feet tall, and they're maybe 3 feet by 3 feet in size. The one on the right is a little bit larger. It's about 4 feet tall and tends to be about 4 by 4 as well. So it's kind of a cube in that regards. Now, there are obviously different types of containers. The ones that we see used in automatic storage and retrieval systems are much smaller. They tend to be in the ballpark of about 2 feet in length and about 1.5 feet in width and about 1 foot tall. So, those are open top containers as well, but the protection for them is covered in datasheet 834. 8-9 would look at something that would end up more or less either in a solid pile arrangement or in a rack storage arrangement. So when you look in 8-9, we do have guidelines when it comes to solid pile protection. Well, the guidelines basically say if I've got this storage arrangement, you treat it the same as if it's closed top storage. We've had that guidance in there for a long time. Now, do we agree with that? I'm not sure if that protection is accurate, because when I look at this type of pallet loads that we now see out there that can be used for solid pile storage, you'll notice that they almost look like portable racks. And so they have a lot of openings through which underneath the pallet load that the fire can spread. And so it almost starts to resemble rack storage. And when we look at rack storage with this type of commodity, we currently at the present time don't have any ceiling only options. And if you have open top combustible containers, our best advice for rack storage is to put them on the lower tier level. And that way you have all closed top containers above, water can land on that, make its way down through the entire height of the storage array, and only the bottom container would end up collecting any water. And so the hazard is much greater, lower compared to being the entire storage height. The other thing you can do when it comes to rack storage is add in rack sprinklers. And that's what's kind of changed in 8-9. We've changed what the requirements are when you come to in-rack sprinklers. You're still recommending them every 10 feet. But if I look at the plan view, we're now looking at protecting them with not only in-racks down the longitudinal flue space, but also at every flue space intersection at the face. So you're looking at roughly a 4 foot by 4 foot footprint between in-rack sprinklers, and we've upped the flow from 30 gallons per minute to 60 gallons per minute based on the heat release rates we've seen with plastic, exposed plastic. So knowing that each of these containers is going to collect water and it's going to collect it for a while before water starts to spill out, we have to get a lot of water going down through the flue spaces at very low increments to try and keep that fire from spreading on us horizontally and providing an adequate protection. So that's currently what we have for open top combustible containers in 8-9.
Okay. And we also see that there's a new table 1A in 8-9. That table provides information on the number of sprinklers per branch line that are required to be included in the hydraulic demand area. So why was that table added?
Great question. So the table is known as table 1A. And so if you think about it, if you're a designer out there for sprinkler systems, you know, the process you would go through to obtain your sprinkler system design, you'd start with 8-9 and find out what your ceiling sprinkler option happens to be, or ceiling and in-rack, depending on the storage arrangement and what you have to install for adequate protection. You would then go find out what your hose demand is, as well as your system duration. Now, once you had that, we have what we call the shape factor, and that's in NFPA 13, it's typically 1.2. Well, we offer that as well, but we modify it based on the ceiling slope that you have at your facility. So it could range anywhere from a 1.2 to a 1.4. And that guidance was located in our datasheet 3-0. So you had just about all the information you needed from 8-9 for design purposes, except the shape factor. So you had to go somewhere else to get that. Well, we decided to change that up and just bring that into 8-9 so that you could get all the information you need for calculating your sprinkler system right here in 8-9. So our table 1A that looks like this is now provided in datasheet 8-9 for convenience purposes. And so to figure out how many sprinklers per branch line to include in your calculation, you just start, first of all, with the number of sprinklers for the ceiling design that you have obtained from the protection table. Then you look at what type of sprinkler you are installing at ceiling level. Is it standard coverage or is it extended coverage? Now the ceiling slope does come into play. Unlike with NFPA 13, they don't look at ceiling slope, but we do. So we know as the ceiling slope changes, it's going to impact how that heat moves around on the ceiling, and it's going to distort the shape of your demand area. So that comes into play. And then we also look at what your online spacing happens to be. And once you have all that, then the last column will give you the number of sprinklers per branch line. And when you look at the numbers we've provided, you notice they're all either 3 or 4. Well, when you used to go to datasheet 3-0, you might have came up with a value of 5 for some of these, and we didn't. That was never the intent. So table 1A helps clarify the number of sprinklers per branch line to include as part of your hydraulic calculations when you do your sprinkler system analysis.
So related to that, there are certain design criteria in FM Datasheet 8-9 that use either a 9 or a 10 sprinkler hydraulic design, even for standard coverage sprinklers. And this is something that was discussed. There were a couple of public inputs that were submitted to the NFPA 13 discharge committee, where they considered criteria to allow certain 9 and 10 sprinkler hydraulic designs in NFPA 13, but the discharge committee for 13 chose to keep a minimum 12 sprinkler hydraulic design, again, for standard coverage storage sprinklers. Since there's 9 and 10 sprinkler designs in 8-9, do you support including those 9 and 10 sprinkler designs in NFPA 13?
Great question. So as you mentioned, there was public inputs to actually bring that information into 13. And in essence, it was when we look at the public inputs, there were a few that were provided by Viking. They had 4 public actually they had more than that. They had 12 public inputs, 3 per table. Table 2331, 2342, 2351, and 2361. They provided 3 public inputs for each of those tables. Johnson Controls, which has the K336, they did the same thing, but they limited it to just 2 tables. They did table 2331 and 2342. And when you looked at what Viking submitted, they looked at actually changing the design. Instead of being 12 sprinklers, which historically has always been the number in NFPA 13, they proposed going down to 9 sprinklers. Now, there was much debate in NFPA 13 about this. Now, one of the things that kind of tipped it into not going to the 9 sprinkler design was looking at what the annex material had for section 24.2.3, and in it, it gives information on it's annex material, so it's not required, but it does give the sprinkler manufacturers some guidance on what might be accepted to the committee for testing to get designs from the testing incorporated into NFPA 13. And so when you look at these 3 bullet points, it looks at storage heights and clearances between the top of the storage and the sprinkler above. And when you look at the test data that was submitted by Viking and Johnson Controls, well, the testing did not include a test where there was a minimum of only 3 foot clearance between the top of storage and the sprinkler, nor was there a test where they went to as much as 20 foot clearance for the ceiling heights they were looking at. And I think their ceiling heights were around 50 and 55 feet high. So according to the annex material, they would have suggested running a test where the clearance was as much as 20 feet below the sprinklers. So because these 2 tests weren't done, the committee was a little gun shy on looking at going to a 9 sprinkler design, but they were willing to accept a 12 sprinkler design. But because now that's going to create some confusion, the sprinkler manufacturers decided to rescind their proposals. And what I mean by confusion is that when you look in their data sheets or even an FM Global data sheet 8-9, when you look at the K28 and the K33.6, you can go into our data sheet and look at table 17B and notice that for those particular 2 sprinklers, they have 9 and 10 sprinkler designs. Now, the question became, do I agree with the steps that were taken by the committee? And so the way I would frame this is that when you look at any design in our data sheets, and I'll stay with 8-9, here in this case, our 9 and 10 sprinkler designs that you see, we indicate they must follow the guidelines that are in 8-9 as well as in datasheet 2-0. And what I will tell you is NFPA does not have the same guidelines that datasheets 8-9 and 2-0 have. So I would have had concerns had they gone forward and accepted the 9 or 10 design and put it in NFPA 13, because they don't have the same guidelines for obstructions or airflow or other things that datasheet 2.0 covers that NFPA 13 today does not cover. Grouped obstructions, again, being another one. So no, I would not have supported NFPA 13 taking on those designs. The way 13 is currently has language regarding the installation rules for the sprinklers.
And so moving from ceiling level sprinkler systems to in-racks, I see there's updates to the guidelines for positioning in-rack sprinklers, and a few of those key requirements are that the in-rack sprinkler deflector must be just below the horizontal rack member and at least 6 inches above the top of storage, but face sprinklers, so in-rack sprinklers near the face of the rack, are allowed to be above the bottom of the horizontal support member where they're offset horizontally by 3 inches.
Mm-hmm.
So it allows the deflector to be above the horizontal rack member, the face sprinkler deflector, where it's offset by 3 inches. So why are those clearances required, and why are face sprinklers allowed to be above the horizontal rack member?
Great question, and I get this a lot. Positioning of in-rack sprinklers. How do we do it? What are we trying to accomplish? And obviously, when it comes to position of in-rack sprinklers, a lot of times it comes down to how do we protect our rack face. We typically have in-racks inside the storage array, but we also need to protect the face. So depending on the storage height and the rack depth, we have new guidelines when it comes to the in-rack sprinklers that take it, and instead of just moving it down the center of a rack where it's up to 3 feet, if suddenly now I'm over that distance, I might need to move my sprinklers and create face sprinklers even for a single row rack. Or the same thing might apply for a double row rack when it comes to its depth and what it's trying to protect. If the storage happens to be over 25 feet, we might suddenly need to move them to a new spot to provide better protection. I don't want that sprinkler too far away from the face. And when I look at the protection of the in-racks, here's a new figure that's in 8-9. And really what we're trying to do is find new ways to protect in-racks, because one of our leading losses with in-racks is them getting hit and causing water damage within our storage array. So when I look at this elevation view of a storage rack, what you see there in the longitudinal flue is our traditional single horizontal support. But what we've recommended the clients consider is at the face, putting in a double horizontal support at the rack face. Now, when you look at the longitudinal flue that's in this, the longitudinal in-rack deflector needs to be at or below the bottom of the horizontal support. And if I do that, what happens with this, if I try to load, bring in my load, it has to go underneath the double horizontal support. And when I do that, I can see now I'm creating a safe zone for my in-rack sprinklers, both the longitudinal as well as the face. So here, in this case, I've got my longitudinal in-rack sprinkler at or below the bottom of the horizontal support, and so the deflector's there, but it's still out of the way of getting hit. And where I've got my face sprinkler now located at or above the bottom horizontal support, it's also in a safe zone as well. So as you were mentioning, what about any potential obstruction to my face sprinkler discharge, because I've got it now tucked above the bottom of the horizontal support? Well, let's take a look and see what we're really trying to accomplish with our in-rack sprinklers. So when I look at my longitudinal in-rack sprinklers, you'll note that they aren't over the top of storage. So the commodity comes in that rests on those horizontal supports, but I usually end up with anywhere from a few inches to maybe as much as 12 or even 24 inches in there with my in-rack is installed in longitudinal flue. It's not over the top of storage. So what I need to do when it operates, I have to have room to allow that water to get from the discharge underneath that horizontal support so I can get it to the top of storage. So I've got to get it under that horizontal support to achieve that. That's why our longitudinal in-rack sprinklers have to be either at or below the bottom of that horizontal support, because I have to go from an area where I don't have storage below it to get it over to where that storage is. And I also have to provide adequate clearance, because as the water comes across, I want enough space to avoid hitting the side of the box. I want to get it to the top of the box so it can then run across and then potentially run down the face as well. So I've got to have adequate clearance when I have in-racks in the longitudinal flue. But when I look at my face sprinkler, the face sprinklers are at or above the bottom of the horizontal support. But the nice thing is they're already over the top of storage. So I don't have to worry about discharge trying to reach the storage and hit the top of it. I'm already going to do it. So when that sprinkler does go off, even if I'm the horizontal support is blocking discharge, what is blocking is water going out in the aisle and wasting it. So it actually captures water, puts it back down the top of storage, and now it can run down through the flue spaces and on the face the way it's supposed to work. And what that does now is allows the sprinkler discharge to reach the top of storage. So by positioning these sprinklers the way we've indicated in this figure, it not only protects them, but it still allows them to provide adequate discharge to protect all the storage that's located within the racks.
It makes so much sense when you lay it out in the figure, Wes, right?
Figures always help.
Very helpful. So another update on in-rack sprinklers that might be easy to miss as someone's going through the revision 8-9 is that quick response sprinklers are now required for all in-rack applications. And that's different from NFPA 13, where standard response sprinklers are still permitted in a lot of in-rack applications. So why are quick response sprinklers, in FM's opinion, better than standard response sprinklers for in-rack applications?
Great question. So when it comes to quick response in-rack sprinklers, it's just think of, obviously, if I have a fire, the first thing I want to do is get that in-rack to go off as quickly as possible. So our previous guidance used to be anything that was a K11.2 and smaller sprinkler could be acting as a quick response. I mean, in-rack sprinkler could be quick response. We recommended that. If we went K14 and larger, it could be either standard response or quick response. You know, we still were pushing the quick response, but it could be standard response. Now in our new guidelines, that has changed. We want all of our in-rack sprinklers to be quick response. We don't plan on going back and causing any retrofit options. Obviously, the protection guidelines we showed in 8-9 before with standard response in-racks still work. But what we want to do is promote better sprinkler protection when it comes to in-racks. So let me show you a test video that shows standard response in-rack sprinklers. And now what we're trying to protect here is carton non-expanded group A plastics with a storage height of 55 feet and a ceiling height of 60. The flow out of the in-rack sprinklers is going to be 30 gallons per minute, and our sprinklers installed horizontally every 8 feet and in-racks every 10 feet. So when I have combination of ceiling and in-rack sprinklers installed, for the in-rack sprinklers to be effective, what they need to do is not only trying to stop horizontal fire spread, but minimize how many ceiling sprinklers I open at ceiling level. Because if they allow too many too many ceiling sprinklers to open, it's going to take away from the water trying to protect it in the rack and overtax our sprinkler system. So let's take a look and see what happens in this fire test video. Now, what I'm going to do is I'm going to use this, and pretty soon you're going to see us give two little graphics on the right side. You'll see how many sprinklers that might be open at ceiling level, as well as the temperature up at ceiling level that's taking place during this fire. So obviously, when it comes to temperatures at ceiling level, we want to try and keep that no more than 1,000 degrees Fahrenheit, because most buildings that we see are made out of steel. And we don't want to start to compromise the structure that's actually holding our sprinklers in place. So we want to try and keep that at or below 1,000 degrees, which is the magic number where steel starts to lose its integrity. And we don't want that to happen. So as you can see, our system, our fire has taken off, and we're already starting to get up around 1,000 degrees at ceiling level. And we're opening up a whole bunch of ceiling sprinklers as we go. So as you can probably imagine looking at this, even though this has in-rack sprinklers installed within the rack structure, they're not being very effective. And these are standard response sprinklers. So let me go ahead and change this over now to the same kind of test using quick response sprinklers. So again, exact same conditions, but now we're swapping out the standard response sprinklers with quick response sprinklers. And again, I'm going to give you the time temperature curve here. You see on the above, and then how many ceiling and in-rack sprinklers actually operate during this test. Now, because these are quick response sprinklers, they will actually go off sooner compared to standard response. And so as that fire is trying to make its way up towards the ceiling, I've got sprinklers that are operating sooner now within the rack and putting water onto that fire much sooner. And as you can see now that the water coming out of those sprinklers is doing a much better job of protecting that fire. So what was not acceptable for protection with a standard response in-rack sprinkler actually now can work if you change it over to quick response. And here you can see that we've had a few in-rack sprinklers operate, and now we basically suppress that fire just because we changed it from standard response to quick response.
It's nice to have the data, right, Wes? Nice
So I tell you, I have the best job on the planet.
Yeah, to support what you do. So what we're looking at here is a traditional in-rack sprinkler system that's working together with the ceiling level sprinkler system. Over the last 5 to 10 years, we've seen new sprinkler systems, in-rack sprinkler systems come about that work independent from the ceiling level sprinkler system. And so NFPA 13 has those systems in the 2019 edition, 2022 edition, and to give you some credit for what you did in 13, those who now have the 2022 edition, if you look in section 25.6, those independent in-rack systems are now, I think, laid out in a lot better way, a lot easier to understand, a lot easier to compare the options, and really Wes had a lot to do with putting that together and making it.
You give me too much credit. You actually were the one who suggested that. So thank you, Steve.
I made the suggestion, did a lot of the work, Wes. So that turned out really well. And then in 8-9, there's been some changes to what I call the ESFR in-rack system. And in 8-9, it's actually called the Alternative In-Rack Sprinkler System Design in section 2.3.6.6. And that system uses K14 and larger quick response storage sprinklers in FM lingo, commonly called ESFR sprinklers. And it allows in-rack sprinklers that are spaced up to 30 or 40 feet apart vertically. Again, and that depends on the commodity that's being protected as well as the sprinkler. So one feature of that in-rack system is that the in-rack sprinkler system is not required to be added or balanced with the ceiling level sprinkler system. So that's really important, right, in the hydraulic design and making that work. And the hydraulic demand is shown in tables 15 and 16, but that has some changes in the latest interim revision 8-9. The hydraulic demand requirements are a little bit different for that ESFR in-rack system. Can you tell us about those changes to hydraulic demand?
Sure. Let me first start, in case anybody's not familiar with this concept of using ESFRs as in-rack sprinklers. So when you look at our previous in-rack guidance, in essence, using standard traditional sprinklers, we had storage heights. If you went over 25 feet high, you had to have in-racks in the longitudinal and at the face for protection. And typically you would put them every 10 feet vertically. Your flows were typically 30 gallons per minute. You would not be able to leave more than 10 foot of storage above the top level of in-racks, and sometimes it was limited to 5 feet in NFPA 13. And of course, then you had to hydraulically balance your ceiling system with your in-rack system. So forever, that's how we did ceiling and in-rack sprinklers. So what if instead of using a K56 sprinkler, we used an ESFR sprinkler, because they're able to protect storage heights up to 40 feet high. So if they were able to be used as in-rack sprinklers, the question became, could they allow us for greater vertical increments between in-rack sprinklers than what we typically used that gave us 10 feet? Could we allow more storage above the top level of in-racks instead of just 5 or 10 feet? Could we go more than that? And could we somehow eliminate the need to hydraulically balance the ceiling in the in-racks? So if you went back to the June 2015 edition of 8-9, and it's in section 2366 today, we can actually use our ESFR sprinklers as in-rack sprinklers. And our vertical increments can range all the way up from 30 to 40 feet, as you mentioned, depending on the commodity we're trying to protect. And believe it or not, we can now leave as much storage above that top level, as much as 50 feet of storage, depending on what sprinkler you're using, and you eliminate the need for hydraulic balancing. So let's kind of review how this works. I'm going to give you a quick example. I know we're starting to run out of time, so I'll run through this real quick. Let's say you had a 80-foot high ceiling with 75-foot high open frame double row rack storage, carton non-expanded group A plastics. In that ceiling, somebody installed a quick response K22.4 pendant sprinkler designed for 12 sprinklers at 50. So let's compare what you would need for in-rack protection using the traditional K56 and using today's guidelines with the K22.4 ESFR sprinkler. So here's a plan and an elevation view of our example. So if I went to the traditional in-rack arrangement that you would get using section 234 of 8-9, I would end up with in-racks at every flue space at the face and at the flue per our figure 13. And we would have to install them every 20 feet vertically, which is shown in figure 15. And then our in-rack design would be 14 sprinklers at 30 gallons per minute, 9 sprinklers from 20 psi for my ceiling sprinkler, and the hose would be 250 and 60 minute duration. And we have to hydraulically balance all this together. But if I go and use the new section 2366, when I look at the in-rack arrangement, the horizontal layout is pretty close to what we previously needed, but now I can go every other transverse flue space at the face. Instead of using the K56, let's say I use that quick response K22.4 pendant. If I do that, now I can go every 40 feet vertically. So a lot less in-racks vertically. Now, do I need another level of in-racks? Well, the way to find out is to go and realize that I'm creating a virtual floor now at that 40-foot level by putting those in-racks in, leaving me 40 feet above to protect from the in-racks to the ceiling above. So I only need one level if I can find a ceiling only option in my data sheet for carton non-expanded group A plastics. And so when I look at that table, which is table 8, for a 40-foot high ceiling with the K22.4, I can see there is in fact a design there that allows me, if my water supply can meet that, I only need one level of in-racks for that 80-foot high ceiling. So in that case, now my in-rack design becomes 6 sprinklers at a flow of 120 gallons per minute, and I only need a duration of 60 minutes with a hose allowance of 250 gallons per minute. So it becomes its own little system that you design, and now pretend there's a floor over that. So the ceiling protection above doesn't know there's a fire below it. So you can now design the ceiling above as if there's a floor at where those in-racks are. So when I look at the ceiling requirements, I need 9 at 50 from my table 8 with that sprinkler, 250 for hose, and 60-minute duration. And the nice thing is, as you mentioned, Steve, the ceiling in-racks don't have to be balanced together. So what does this look like? Let's take a quick look at a side-by-side test video where I've got 30-foot high in storage up to the in-racks up to 30-foot high on the left, using a K14 at 65 gallons per minute. And on the right, I've got the in-racks at 40 feet high, using a K25 at 120 gallons per minute. So when you watch this video, I know it might be hard to see, but try and keep an eye as to when the first sprinkler operates and where the fire is in the rack to give you an idea of how soon those in-racks can actually go off. Now, at this point, you can see I've got flames at about the top of the 3rd tier, and they're starting to make their way up to the top of the 4th tier. But since I've got quick response in-rack sprinklers, my first sprinkler has just now gone off, and it's starting to put water down, and it's not only controlling this fire, but you're going to see it's going to basically suppress this fire. So very little in the way of fire damage, very little amount of water damage, and not much in the way of smoke damage compared to traditional ceiling only systems. So here we are at the 7-minute mark. my fire on the left and right is almost gone. And if I let the video run a little bit longer, on the fire on the left basically does the same thing. So, and this option is also available in FP13 as well. The one thing that did change was that when you look at what we had a design that required ceiling in-rack sprinklers and two adjacent racks to be included in the design. It used to include the exposed non-expanded group A. We took that out, and now it's only applying to exposed expanded.
Okay, and those are, there's the ESFR in-rack system, there's an EC in-rack system that are both in 8-9 and NFPA 13.
Correct.
So there's a lot of good options for in-rack sprinklers, and some people think, well, I don't install them unless I have to. Well, guess what? There's a lot of times when you have to these days.
That's
Either
right.
storage or more hazardous comes up pretty frequently. Final question for me. What are you working on next? We have 8-9 recently revised, 2-0 was just released. What's up next for you?
Great. I'll take this opportunity to quickly talk about future changes to 8-9, either in the 2022 or potentially the 2023 edition. One of the things that we are looking at right now, we talked about open top combustible containers, and there's no ceiling only options available today. Well, we're hoping that our testing will that we're doing right now will lead to some ceiling only options that are available, so you don't have to put in-rack sprinklers. Now, it's going to take a change in the container so that there's some type of venting provided. But if it works, we'll bring that information, make it available, let our clients know what they have to do to the containers for venting, so that when the water goes in, it comes out basically at the same time, and what type of ceiling protection they might need to get away with that. We also are, as we talked about multiple racks, we're looking into how do we protect them. So we'll hopefully come up with some new guidelines then. And one of the things we're going to be doing is kind of is going to make my life a little bit more challenging the next couple of years, is we're going to make 8-9 a one-stop shop for all the things that you would normally find with either class 1 through 4 and plastics, as well as pallets for protection, and put them all into 8-9. So all these data sheets you see, 824, 833, and 834 are going to get moved into 8-9. And so anything that's class 1 through 4 and plastics will be you'll find your information there. In terms of 2.0, it just came out, a few weeks old. So it was released technically in last month, but at the very end. Three things that are really new that you should check out is now we have, when it comes to obstructed ceiling construction, ESFR is basically used to be required in every flue space channel created by obstructed ceiling construction if the vertical structural members were deeper than 12 inches. Well, that's not the case anymore. In fact, we have some guidance as how you can install them on their normal spacing, even if the structural members go as deep as 24 inches. And when it comes to slope ceilings, we are finding that now we can find ways to install ESFR type sprinklers, even when the pitch of the ceiling goes more than 2 and 12. And similar to what was introduced in NFPA 13, we now have some guidelines for obstructions that are less restrictive compared to what it was before.
A lot going on there, and it's nice to see things moving quickly, because the reality is designers and installers don't have customers who are saying let's wait for things to be developed. They want to get buildings built now, and it's good to see the guidance being updated so quickly to address that. So we've reached the end of the allotted time. If you wouldn't mind, Wes, we have some good questions in the Q&A that I
Sure.
don't just breeze through. Maybe I'll start with and try to bring them together by topic. And go. So the in-rack sprinkler positioning guidelines that you just went through, and things like allowing the face sprinklers to be higher than the front beam, that are now in 8-9, do you think those are going to end up going into other data sheets like 731 on aerosols, 729 flammable liquids. Do you think it's going to same guidance are going to go throughout?
Yes, in fact, one of the things we're going to try and do to make it consistent is to move all that information into datasheet 2.0 as well, so that if you when you look at in-rack protection and where they can go, the occupancy specific data sheets such as a 729 or a 731 will give you the design and spacing of it, but 2.0 then will give you the guidelines of how to make sure that they're properly positioned to avoid damage, as well as where they should be located to achieve adequate discharge without obstruction.
Okay, so that should end up being consistent once everything gets changed. In the in-rack systems that we talked about, where you have maybe a 4-foot spacing between in-rack sprinklers, any concerns about cold soldering there?
Not really. If you think about it, when it comes to in-rack sprinklers, and this applies to closed top storage, in that if I have an in-rack go off, that means the fire is probably in that flue space. So, and of course now we're recommending quick response. So once that sprinkler does go off, it's throwing water not only in the flue space it's located, but it's going to go across the top of storage and go down adjacent flue spaces as well. So all I need is that first sprinkler to go off. It's protecting its flue space and the adjacent 2 flue spaces on either side of it. So it's actually doing the work for the sprinkler that would have been located right next to it, that if you cold solder, it doesn't matter, because that one sprinkler that went off is doing the job the adjacent sprinklers would have done for it. So it's just making sure that when I have it on a 4x4 foot spacing, I get the quick response. I get that first sprinkler where the fire is closest to going off, and now I've got good coverage for all the flue spaces that are around it.
And moving out of in-racks for a second here. Well, maybe it is in. So if someone has a open grate PIC module that they're trying to protect with open racks, and the walkways are sort of open grate, does FM Global have protection criteria for that? How would someone address that in FM Global's requirement?
Well, that's a great question. We'd have to look at how the picking happens to be. Those are probably going to be open top containers, if based on the ones I've always seen. And so if you've got open top containers in there, you're going to probably need some in-racks over top of them, because the ceiling is going to be slow in getting water down to them. So it's a matter of looking at, do I have plastic containers? Do I have cardboard containers? What's in it? How high is it? Those sometimes are things that might be a little bit outside the box that you have to work with your local field engineer at FM Global to find how best to protect the specific scenario you have.
Okay, and there's a question about, and I'm gonna maybe answer part of it as I ask it, but there's a question about, and I think this question is really trying to focus on the alternative in-rack sprinkler system with the K14 and larger quick response sprinklers. But it's a question about, are approved in-rack sprinklers required for that? Now, so in the FM Global, FM approvals world, an intermediate level sprinkler is one with a water shield, right? That's how that's defined.
Right.
So for the alternative in-rack sprinkler system, is that required to be an approved intermediate level sprinkler, or is a regular FM approved ceiling level sprinkler okay?
Yes, in fact, the language in datasheet 8-9 simply says what you could do is take an FM approved ceiling sprinkler and use it as an in-rack sprinkler. Now, since the concept is we have the fire grows, gets to one level of in-rack sprinklers, the one that's closest to it vertically, we anticipate that level of in-racks are going to go off, and that's it. The fire is going to be suppressed. So we're not going to have multiple levels of in-rack sprinklers going off, and as a result, you don't need water shields for them. So you're just simply taking a ceiling level sprinkler using it as an in-rack, and it doesn't have to be listed as an in-rack sprinkler.
And one of the things that happened also in the market is once, we started putting ESFR sprinklers or some larger EC sprinklers in racks, we had some demand come up for guards.
Mm-hmm.
And so we met with FM approvals, and FM approvals came up with a program to approve guards for ESFR sprinklers, essentially, and EC sprinklers for intermediate level use, right? Not for use normally at the ceiling, but
Right.
for these intermediate. So those things became available on the market. It's been a couple of years now since we came out with those. Once that demand developed, right? So that's another option for some of these new in-rack systems.